Right, face front. Please rise. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Saint Michael the Archangel, defend us in battle. Be our safeguard against the wickedness and snares of the devil. May God rebuke thee, we humbly request. And do thou, O Prince of the heavenly host, by the power of God, cast into hell Satan and all evil spirits, who prowl about the world seeking the ruin of souls. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Have seats. One announcement or two. Just as a matter of courtesy, I'm usually, you know me by now and know that I'm relatively laid back and easygoing. However, if you chit-chat all the way through the hour, that does get on my nerves and it's rude. Please do not do that. Especially if I ask you to be quiet, respond. Don't just ignore me. That really gets on my goat. Makes sense? Right. There are a couple things happening today. Number one, I do have a few new notes for you. Then we're going to give you a little bit more time for work on the, I'm going to check off the first half of the assignment. I want to get the notes out of the way first because I want to make sure we don't run out of time. It's a strange topic, but it's relatively easy to do once you get the track. So if you'd be so kind, take your notes out, please. I want to talk about something called forward, backward problems. Now, before I can explain what that means, this is an example. The sine of some angle will always give you some sort of fraction. And it's opposite of hypotenuse, it's running in a triangle. Can anybody tell me, has anybody ever seen this before? What is it? Yeah.
Isn't that called like inverse sine?
It is inverse sine. What does inverse mean? We've used inverse functions before. What does that mean? When you're going inverse. It sounds a little like the gear of a car. And very closely related. What do you think? What's different? Yeah, in reverse. Inverse, think reverse. It means it goes in the backward order. An inverse undoes something. An inverse undoes something. So in other words, what's the inverse of multiplication? Division. What's the inverse of addition? Subtraction. What's the inverse of square rooting? Squaring. Make sense? Does anybody happen to remember the inverse of absolute value? How do you get rid of them? Splitting. Good. Splitting is the inverse of absolute value. Subtraction is the inverse of addition, and so on. This inverse sine, or you could call sine inverse if you wanted, is the inverse of regular sine. How does it work? It means that if it goes in reverse, if you plug in the fraction, it should give you the angle back. And actually, you may not have realized that you've been doing this for the past week without knowing what it was called. Quick example. Cosine of theta equals 1/2. And I'm going to limit that to just once around the circle. So from 0 to 360 degrees. Can somebody solve that for me? Just as a practice. This will be tipping. Everybody should be relatively comfortable with this by now. Michael.
16
Say again, I'm sorry?
300.
Yeah, how do you get that?
In a circle.
Okay. And what is cosine?
Left, right.
Left, right? Is it left or is it right? Right. A lot or a little? A little. Exactly. That's where you get 60 degrees, 300 degrees. Make sense? What you just did in your head is this. Take a look up here. Technically, how would you get theta by itself? And this is a rhetorical question. A lot of people assume, well, you divide both sides by cosine. You can't. This is not cosine times theta. It's cosine of theta. This is an input of the same function. You can't split it apart. What you can do to cancel a function is to take the inverse function of both sides. The cosine and inverse cosine cancel. Theta equals the inverse cosine of 1/2, which, by the way, is exactly what you just gave me. You did an inverse cosine in your head, which is nice. Does that make sense? So when you go back and find the angle that caused it, you have done an inverse function in your head. You went back and found the angle or angles. Okay? Now, a forward-backward problem refers to these. Regular sign is going forward. Inverse sign is going backward in reverse. A forward-backward problem is where you try and do both at the same time. For example, the sine of the inverse cosine of 1/2. Let's try that. Now, way back in first year algebra, when you have parentheses inside parentheses inside parentheses, what do you do first? Yeah, when you have parentheses inside parentheses inside parentheses, what do you do first? Innermost parentheses first, correct. So here, you look at the 1/2, that's the innermost. There's not much you can do with that. It's 1 divided by 2. It doesn't reduce. So go to the next layer out. The inverse cosine of 1/2. You've actually done that already. So, let's try it. What is the inverse cosine of 1/2? There are actually two answers. Oh. Yeah, in other words, when you do an inverse function, you should get theta, or more than 1 theta. This is kind of asking, let me put this up to the side. The inverse cosine of 1/2 is basically asking you what angle theta does give you 1/2. So it does. What do you think? I'll probably go ahead. Give me an angle that actually makes that work.
Wait, sorry, can you repeat the question?
What angle actually gives you a cosine of 1/2?
60.
60? What else?
300.
Yeah. Now the question is, I want the sine. We're actually going to get two different answers here. And then we can make first. What's the sine of 60 degrees? B. You need to look at the unit circle of that out too. You're going to get two separate solutions here.
Wait, so do you mean like sine of 60?
Sine of 60.
Dash radical 3. And then, oh no, is it radical 3 over 3?
Close. That's a tangent value.
Oh, is it going to be radical 3 over 2?
Radical 3 over 2. That's one of the sine and cosine values from multiples of 30. Let me see. No, what's the other one? What's sine of 300? Got it. Done. As a general rule, if you have to pick one, if the worksheet says just have one answer, if it insists on one answer, pick what we call the easiest. What that means is that it is closest to 0 and positive if possible. So which of these two would you prefer, just off the top of your head? Back off.
Positive one.
Absolutely. I would take that as my final answer. Okay. That's one way to do this. I'm gonna show you actually pretty much a guaranteed way to do this. So it takes all the mystery out of it. But forward backward problems look weird. There's no getting around that. What if I do this? The tangent of the inverse sine, and I'm about to throw you a curveball. 4/7. Four over 7, does that look like a common fraction or an uncommon fraction? Uncommon, definitely. Why? Like, give me a common fraction, like where you could run into the sines and cosines. 1/2, do another one. Here. We got 1/2, what's another common fraction? Radical 3 over 3 for tangent. Polly, give me another fraction that's common. Radical 3 over 2. Sophie, give me another one. Any value that would make a common angle. So 1/2, radical 3 over 2, radical 3 over 3. Regular radical 3. How about on a unit circle? So this is sine, cosine, tangent. Radical 2 over 2 is multiple of 45. We'd missed that one, correct? No. 1. Yeah, sine is equal to 1 on top of the circle. Give me another one. 0. Give me another one. -1, exactly. Those are common. None of the things we've ever covered is 4 out of 7. So how on earth are we supposed to do this? The technique for a forward-backward problem is this. Step 1. Please write this down. Draw a trig shape. I'm going to put in parentheses, usually a blank right triangle. I'll explain what that is in a second. And put theta somewhere inside. Go ahead and write it down, Alex. It's easier to show you than to tell you. But draw a trig shape, usually a blank right triangle, and then put theta somewhere inside. Step 2, put the numbers from the fraction from the input in. Where it makes sense out of the inverse trig function. In other words, we're going to take the 4 and the 7 and put them somewhere where it makes sense. And then step 3, solve. Usually with SOHCAHTOA. I probably shouldn't say solve. I just say find the answer. Because solve means get x by itself. Now, I'll have to talk you through this. It's actually very easy to do once you get used to it. Let me try. Okay. In a sense, it's actually easier than using the unit circle with our trying to find the regular solution, shadow solution stuff. What's step 1? Does somebody talk me through this? Sophie, what's step 1? Yeah, draw a blank right triangle. Here's what it looks like. Make sure it's a right triangle. Just leave it blank for now. Okay? It says put theta somewhere inside. Then there are 2 places you could put it. You could put it on the left angle or on the top angle. Don't put it in here because I need the right angle. I like putting it on the left for, I'm not sure why. It just looks nice. I'm done with step 1. That's all you have to do. Step 2. Put the numbers, remember you have to do the inside layer first. This is basically saying the sine of some mystery angle is equal to 4/7 over 7. Can somebody put the 4 and the 7 where they would make sense? Illustration. If this is theta, and the sine of theta is 4 over 7, think SOHCAHTOA. Where would the 4 and the 7 go?
The 7 to do on
7 side 5
and the 4 would be
is what? I'm
short
sorry?
side.
Yeah, short side, the opposite. Does that make sense? I will add one thing. The third side, you may need a squared plus b squared equals c squared. Diagram here. Can somebody find it for me? How big is this side? Step me through it. Big.
Well, you could figure out that 7C, so you could do 49
Okay.
equals, and then you could do 16 plus B squared.
Yeah, let me see what we did. It was 4 squared plus b squared equals 7 squared. A squared plus b. It was written all backwards, but that's okay. Dig for b for me.
Or you could subtract 16.
Okay. What do you get?
33.
33, correct. One more step.
Would, square root of that.
Okay, how many answers? 2. What kind?
Positive.
In this particular case, when I'm looking for the length of the side, do I want both? No. Explain.
Well, 'cause you can't have a negative measurement on the side.
Exactly. You can't have a negative distance anywhere. So just use the radical 33. That actually takes half of your work out of your way. Is everybody okay with step 2? Step 1 is just draw the triangle and put theta somewhere. Step 2 is put the numbers where they make sense and find the third side. Step 3, you remember inverse sine should give you an angle. All you have to do is look up here for a second. Find the tangent. Because, Michael, do SOHCAHTOA for me. Find the tangent.
So, from there,
Yeah, exactly.
4 over radical 33.
Right, get the radical out of the way.
Oh, yeah.
How do you get the radical on the basement?
Well, you have to multiply by radical 33 over radical 33.
Correct. What do you get?
Oh, 4 radical 33.
Over what?
33.
Yeah. You have just answered your problem. That's called the forward-backward problem. It looks very complicated, but all you have to do is set, the most complicated thing in there was actually just getting the radical off this one. All you have to do, set up the triangle, put the numbers where they belong, and then do the outside trig function, and you're done. So, which I know. Let's try the cosine of the inverse sine of 7 over 25. Sophie, start me off. What's step 1? Okay. Like what triangle? A blank right triangle. Okay. What now? So we keep going. I'm sorry. Put theta somewhere. Your preference? I don't know. It doesn't really matter. You could put it here or here. Okay, put it here. And finish this off for me. Can you put 7 and 25 where they make sense? Don't do the cosine, because you get to do the inside first. Where do you put the 7 and where do you put the 25? Yep. Adjacent is, opposite of adjacent is tangent. What is sine? Hypotenuse. 25 is hypotenuse. Can somebody find the missing side for me? Julie Sisha. Tell me how to do it. How many are 25 squared off the top of your head?
You said 625.
625, yeah. Keep going, Julie. Okay. And I'm curious if anybody remembers this from geometry. This is actually a common triangle.
576. Well, I mean,
Yeah.
it's 20, it ends up being 24, but
576, and yeah, if you take the radical, on both sides,
724.
yeah, this is b equals 24. Okay, now, Julie, I want you to keep going on this. There's one last step.
Cosine is 24 over 25.
And you are done. That's a forward factor problem. Does that make sense? They're tricky, and you need the trick in order to get the problem done. I want to do one more because I said usually a blank right triangle. There's only one exception that I know off the top of my head. Just gonna get a little space here. The sine, the inverse cosine of zero. Step one is draw a trig shape. Usually a blank right triangle. We got an issue here. You can draw a blank right triangle, that's not a problem. You can put theta somewhere. Does anybody see what's about to be the problem? What's wrong? No.
We can find like 0.
Yeah, I dare you to do adjacent over hypotenuse 0 over something. It's like, huh? It's something over 1. You just crushed your triangle to death. There is no such thing as a triangle with a 0 side. There's only one shape that does allow values of 0. Okay. Unit circle. Draw a unit circle. It's a trig shape. Mark theta though. Where is cosine equal to 0? Okay. There are actually two spots.
Well, to the right, and the,
You can ignore that over 1. Where's cosine equal to 0? What is cosine?
it's left right.
Left, right. And if it's left, right, 0 spaces, where are we?
It's just on the,
It's gotta be on the circle. This would be a cosine of 1.
a little bit up,
Yep, so where is that?
and then,
Where's the angle?
was that 90?
It is 90 degrees. Where's the other one?
And that 270?
270, got it. Now, can somebody give me the sine values of those? You are gonna get two different answers. You did the inside, ta-da. Now give me the outside. Jackpot.
Okay. Wait, sorry, what? What did you want me to do?
Do the final step.
Oh, so cosine would be,
We got cosine already. This is
I
doing
mean, the sine.
inverse cosine, yeah.
the
that's
sine would be, would it be 1 over negative 1? I don't know, I was trying to catch up.
All right, let me step through. Step one is draw the shape, and then mark theta.
Oh, you have to draw the unit circle for this one?
Yeah, why? You tell me.
Because it doesn't work on the,
Yeah, the right triangle doesn't work. You can't have a length of 0. Unit circle is the only one that can have 0 as a value in it. So the purpose of the inside layer is to find out what shape it is and where you are. So basically, it's asking for the theta. There are actually two different thetas you could work, 90 and 270. The inside stuff is done. By drawing the picture, you've done the inside. Find the sine of those angles. That's what I asked now. What's the sine of this?
1,
1 or
negative 1.
negative 1. That's your answer. That make sense? Usually you're going to get one answer, the easy one. On rare occasions you get two. Feel my candles? All right. Your assignment, I don't think you need any, did anybody want to go through any of the problems on the worksheet from yesterday? Everybody feeling okay on that? I'm going to check out the first half of them, and then I'll read off the answers, yeah. I want to hand these out. They are not due Monday, they're due Tuesday. entire thing is due Tuesday, so we want to get an early start on it, you're welcome to. I'll leave that totally up to you.
Wait, what about the second half of this?
Second half of that one is due Monday, this is due Tuesday. I'm just giving it to you ahead of time. So if anybody wants to get started while it's fresh in their mind, you're welcome to do that. Okay, let me come around and check the first half, which is 1 through 9, on the first worksheet.
There's supposed to be parentheses.
A big part?
Is this-
Oh, yeah, the worksheet is notorious for not putting parentheses in there. You feel free to put parentheses around the inside stuff. Yeah, it drives me nuts when I do that. But, what do you do? Alright. Oh, right. So we can get the whole thing done Monday. Alright. Let's get some answers. There are. Yes, got it. So you got 1 through 6, you just had to do the normal two solutions in radians. So number 1, you have theta equals 0, and theta equals pi. Number 2, theta should be 3 pi over 4 and 5 pi over 4. It repeats over. Number 3, two solutions, identical to number 1 actually. Theta equals 0, theta equals pi. Number 4, theta equals pi over 3 and 4 pi over 3. And number 5, theta equals 5 pi over 6 and 11 pi over 6. And number 6, there's only one solution. Theta equals 3 pi over 2. Next page, any reviews on the first page? Okay, next page. Number 7, theta equals, there's only one base solution. So it's theta equals 3 pi over 2 plus 2 pi k, parentheses, k is an integer. 3 pi over 2 plus 2 pi k is an integer. Number 8, there are two strings. First is pi over 6 plus 2 pi k, k is an integer. And the other one is 11 pi over 6 plus 2 pi k, k is an integer. Did we get that? And number 9, theta equals, there are two strings. Theta equals 2 pi over 3 plus 2 pi k, k is an integer. And theta equals 4 pi over 3 plus 2 pi k, k is an integer. Any repeats? Questions? How'd it go? Easy, hard, medium? Okay. Did we okay on converting to radians, or doing it radians in the first place? Okay. Anyone who got stuck on? All right. Looking good. So the second half is just more of the first. 13 through 18, you will have to factor. I want to go through and give you a little bit of a favor and tell you how many solutions you're going to get. Well, you know, how many strings you get. You've seen the difference, like sometimes you only have one string and sometimes you have two. I'll tell you right now, number 13, you have two strings. Number 14, you have two strings. 15, you have four strings. 16, you have two strings. 17, you have four strings. And 18, you have two strings. Okay. Some of those, if you square root both sides, don't forget plus minus. That will help you get the number of strings you need. And that, I believe, is all I have for you. So if you want to go ahead and start plowing away, I would finish that one first. I mean, if you want to change the pace, go ahead and do the forward-backward problem too, just to refresh yourself. But other than that, the worksheet should be done in its entirety. 7F should be done in its entirety by Monday. And then 7G, which I just handed out, should be due on Tuesday. And John, I'll email you one of those. And I think that's it. So, God bless, recover quickly, we miss you. Talk to you later, bye.